Good day, everyone. Welcome to Engineering Data Analysis. Now, for today's uh, discussion, we will be talking about three main topics. We have the engineering method, the statistical thinking, data gathering and sampling techniques, sample size determination. Specifically, this video will discuss about engineering method and statistical thinking. In this lesson, we will be able to identify what is an engineer, what is the role of an engineer in statistics or in doing statistical study. We will also be discussing the different terms that we might encounter um, upon the discussions of the next or the other modules. So let's start. Let's start with the definition of an engineer. An engineer is someone who solves problem of interest to society by the efficient application of scientific principles. So, they said that engineer comes from a word which is ingenieur, or which means ingenious or a product of a genius. Now, the purpose or the goal of engineers is to create solutions to problems of society using science, discoveries, or technologies. So that is why in um, if you can observe, so many of the products or the outputs of engineers were actually applications of scientific studies or scientific principles and technological outputs or products. Now, in it, the method of formulating or solving problems which are done by engineers are is called the engineering method. It's a scientific approach, a scientific method, which is the approach to on how we formulate and how we solve problems. In the engineering methods, there are several steps on what will we do so that we can solve a specific problem. Here are the steps. The first one is develop a clear and concise description of the problem. We must be able to describe and identify what the problem really is. Second is, at least tentatively, we have to formulate or identify the important factors affecting the problem. So that may result its a solution, or otherwise we call it formulate uh, the the possible um, the possible factors. Okay, what are the possible causes of this problem? Okay, what are the factors that affect uh, or that may play in the solution to the problem. After that one, when you now identify the factors, then you can formulate an assumption, hypothesis. Now, formulating the hypothesis, then we can propose a model for the problem using scientific or engineering knowledge of the phenomenon being studied. After, we conduct appropriate experiments. So in your some of your courses, for example, physics, we conducted several experiments just to check the behavior of a certain phenomena. Then after, we create a model, a tentative model. Then we refine the model based on the data observed. Then after, we manipulate it so that it can assist us in developing the solution to the problem. Now, we refine or manipulate it further to help us develop the correct solution. Then after Now, creating a solution, so we have to validate it through conducting an appropriate experiment. So, number seven is about validation of our solution to the problem. After that, we then create or infer. Now, we make conclusions or make recommendations based on what we have done in the previous steps. Okay, these are the steps in engineering method. Now, as you can see, you have to take note of steps 3 to 4. Now, we can actually iterate it if in case the proposed model is not yet that effective, then we can reiterate it until we can improve it further. So that's the role of engineers, no, in solving problems. No, we follow what we call the engineering method. Now let's discuss some terms that we might encounter in discussing or dealing with statistics. But before that, let us define first statistics. What is statistics? Now, it is a science of collection, organization, presentation, analysis, and interpretation of a given data. In this definition, we are actually shown or yeah, the different processes or the different steps or methods that we can uh, that involve that are involved in statistics. First is collection. No, we collect data. Then after organizing, we present it and we analyze and interpret the data. In simple terms, statistics is a science of data. And in this data, no, we do different methods, no, or steps from the collection to the organization, then presentation, then we analyze and make conclusions. We interpret um, the results of those or our data. Now let's start with the collection. We when we say collection, we gather data. Now that's called data collection or data gathering methods. There are a lot of methods or techniques in gathering data. So here are some of those. We have questionnaires. Yeah, we use questionnaires to get data, just like surveys. Then we use interviews. We interview people, based on um, or with respect to our proposed study. Or we can have experimentations. If you recall the engineering method, okay, one of the major steps there is to conduct experiments. Or we can do observations, no, for if you just want to check the behavior of some things. For example, if you just want to check the behavior of students entering a campus or entering the school premises, then you can do observations. Then, or you can have test or examinations. Now, if you recall, before you enter the school or during admissions, especially first freshmen, there is an examination conducted to you. So that's one source of or one method of collecting data. Then we present the data, the collected data through a narrative, okay, by describing the data, or we can convert it into tabular form. When you have a lot, especially numerical data, the best thing that we can do is to transform them through into tables or graphs, because some people now prefer graphs than table or narratives. It's like it's appealing to the people when we use graphs to present our data. After that one, when we were able to summarize the data, transform them into tables or graphs or in narratives, we can then analyze the data by using different statistical methods which are relevant to our goal. Okay, so that's how we analyze. Later, we have different tools or methods to on how we analyze set of data. Then we interpret them further. Okay, so that we interpret the data rather, so that we can um, arrive into a conclusion or recommendation, if possible. So in your special project or thesis, you will be doing this one. In the last part of your thesis, you will be presenting a conclusion and recommendation. All researches have actually this one, creating conclusions based on um, the results, no, based on the results of or on the previous steps, and also recommending those possible solutions or possible modifications to a study. So again, statistics is a science of data and how we do or how we um, on what do we do with data. Now we have four major steps. Now we gather or collect, we present them, we analyze them, we interpret the data. Statistics has two main branch, which are descriptive and um inferential. Now, when we say descriptive statistics, so the goal here is just to describe the behavior, the data through organizing and summarizing data, no, through presentation, through graphs, through tables. That's descriptive statistics. However, if you want to generalize for example, a population, you want to analyze a population, then we can have inferential statistics. Okay. If we want to generalize a population, say for example, the um, in Region 10, kinsay who is the bet of Region 10 for presidential position, then of course we cannot interview all of the people in Region 10, so we get um, a number of respondents, which we call sample, no, to represent the totality or the population. So we can use inferential statistics regarding that type of research, no, or study. Then we generalize, no, we create conclusions based on those. Okay, that these are the two main branches of statistics. Again, we have descriptive and inferential statistics. Now, here are some terms. So we have population and sample. So based on my example earlier, the population is the totality, the whole the whole number of different of objects, of people, of places, or of things in the study or being studied. So if we are studying the different species of birds in Misamis Occidental, so that's the population, all the birds in Misamis Occidental. However, if you only get samples of those, no, then that's or a small portion of those, then we call it a sample. Now, the use of samples is to represent the population. Okay, we study the sample or we study the population based on our samples. By the way, have you heard if you heard the word census, that is actually um, getting data. No, the observations were based on the whole populations. That is why we call census. If if uh, if you experience or encounter people going to your houses, counting the number of heads per household, that's called census because they will be getting all the number of people within that household for all of the residents. Okay, that census. No, when the data are all from the population. Then we have parameter and statistic. Now, if you want to measure the population, then we call it parameter. However, if you just want to estimate the population based on the sample, so we call it statistic without S. Remember that statistic and statistics have different meanings. No? Both of them are singular in meaning. Okay, so again, if you want to describe the population, the measure of the population, then we use parameter. Then, however, if we based it on a sample, okay, when we describe a sample or measure a sample, that is a statistic, no, an estimate of the parameter. Okay, then we also have data. So a data is a set of information under study. There are two general categories of data. We call them qualitative and quantitative data. Qualitative, so from the first three syllables of this word, you have quality. Now from it's taken from quality, so these are actually non-numerical data. We can say colors, we can say um, gender, and so on. Then quantitative data are those data which are expressed in numbers, say your height, your weight, your age, and so on. Then we also have a variable and a constant. So a variable, which means any value may be set to to that one. Okay, the value may change at any time, and its characteristics would differentiates a particular member from the set. So, and a constant is a characteristic or a characteristic that is common to all. No? So, for example, if say our study will be about calculators, maybe we can have a variable on the brand of calculators. And the constant is that both of them can add, multiply, and so on. Okay. Again, ano the value of that variable may change depending um, on which field we are studying. So there are classifications of variable, according to functional relationship, to continuity, and to the scale of measurement. Well, we have dependent and independent variables. So dependent variables are those variables which change only based on or when the independent variable changes. So it's affected by the change of an independent variable. If you recall, we have in an equation, if in an algebraic equation, you have, say, let's have y. Okay, y is equal to, say, mx plus b, where m is the slope and so on. Now here we have two variables. Now these two are actually constants in an equation. These two do not change within an equation. However, x and y will change. Now here we identify x to be the independent variable, and whatever happens to x, y will also change. So that's a relationship. No? That's based on relationship. Now, another example of dependent and independent variables. Let's say the s- um, the grade of a student. Now, the grade of a student will be dependent on on how the student studied. Probably our independent variable there would be the study habits of the student, then the dependent variable will be his or her corresponding grade. Okay, so that's an example. Then, if we want to talk about continuity, there are continuous data and discrete data. When we say the difference of these two is, let's just take, for example, real numbers. Now, real numbers have actually has actually a lot of sets. Now we have integers, whole numbers, rational numbers, irrational numbers. Now discrete numbers are those numbers which don't have decimal values. Okay, for example, one, your age is no your age. Now we round our age, except if we want to get the exact age. But commonly, if you are asked of your age, you'll be answering your age is 18, 19. No, you don't answer 18.5, 19.01. Okay, so we can describe, no, based on your answer, if you answer 18, 19, 20, so that can be considered a discrete type or discrete variable. Continuous variables, examples of those are weight. Now, what's your weight? Uh, 60.5 kilograms. Okay, that's an example of a continuous variable. Within a number line, no, if you recall a number line, so any point from the number line, so those are consider continuous variables. Okay, we also have according to scale of measurement. Actually, we can, if you recall the two main categories of the data we have here, we can actually divide these four. So we have nominal and ordinal are qualitative data. So you can have these are under qualitative data, while interval and rational or ratio are quantitative or numerical. Qualitative, other term for qualitative data is categorical. For quantitative is numerical. So nominal, it actually tells us names, okay, like gender, um, like um, your religion. Okay, these are nominal data. Ordinal data, examples of ordinal data are, for example, if I want you to rate how are you feeling right now? Are you sad or very happy? From the range of very sad to very happy. So those are example of ordinal data. If you answer neutral, then that's an ordinal data. So it talks about orders, no, or ranks. Okay, that's ordinal. Then we have interval. So if I would say based on rate yourself from 0 to 9. Okay. We also have rational. This involves fractions. Okay, for example, your temperature. Okay, that falls from a certain value. No, if you use a digital um, thermometer, there are values 36.1, 35.7, and so on. So again, these are just some classifications of variables according to functional relationship, according to continuity of values, and according to scale of measurement. Okay, that's the end of our session for engineering method and statistical thinking. Okay, see you on the in our next lesson. We will be discussing the different data gathering techniques and sampling techniques. So see you in the next video.